What if everything you thought you knew about the universe was wrong? Beyond the brightest stars and swirling galaxies lies an unfathomable emptiness. A cosmic desert so vast, so devoid, it challenges our very understanding of existence. Prepare to journey into the enigma of the void, where even light fears to tread and the universe's greatest secrets are found in its absences. When we look up at the night sky, we see points of light. When we look through a telescope, we see rivers of light, billions of galaxies clustered together in great filaments and superclusters, a magnificent structure we call the cosmic web. It's easy to assume the universe is full. But this is an illusion. The galaxies, the stars, all the matter we can see, it's all just froth on the surface of an immense dark ocean. The vast majority of our universe is, in fact, almost completely empty. These are the cosmic voids, the largest structures in the universe. Some are hundreds of millions of light years across, so empty that if our Milky Way were at the center of one, we wouldn't have known other galaxies existed until the 1960s. This poses a profound puzzle for cosmic cartographers. If the Big Bang filled the universe with matter, why are there these colossal empty spaces? Why are these voids not just empty but so much emptier than they should be? So how do we map something that isn't there? We can't see a void directly. Instead, astronomers map the things we can see. Galaxies. By meticulously charting the position of hundreds of thousands of galaxies in 3D space, they began to see the true picture. The galaxies weren't spread out randomly. They formed a web-like pattern. And in between the bright filaments of this web were the great, dark voids. Observational breakthroughs like the Sloan Digital Sky Survey gave us our first, breathtaking maps of this structure. We discovered colossal walls of galaxies, like the Sloan Great Wall, stretching for over 1 billion light-years. But for every wall, there was an even bigger void next to it. The most famous is the Boots Void, a cosmic desert nearly 330 million light-years in diameter. It's so empty it's been nicknamed the Great Nothing. Discovering these voids confirmed that our universe's structure is far stranger than we ever imagined. To understand why voids exist, we have to talk about the universe's invisible scaffolding, dark matter. After the Big Bang, dark matter, which makes up about 27% of the universe, began to clump together under its own gravity. It formed a vast, interconnected network of filaments. Normal matter, the stuff that makes galaxies, was then pulled by gravity into these dense filaments, like water flowing into a riverbed. The voids are simply the massive regions that were left behind, where there was slightly less matter to begin with. But there's another mysterious force at play, dark energy. This is the force causing the expansion of the universe to accelerate, and it has a profound effect on voids. Because voids have so little matter and gravity, there is nothing to resist dark energy's push. As a result, these empty regions are expanding faster than the rest of the universe, acting like giant bubbles that push the galactic filaments further and further apart, shaping the ultimate fate of the cosmos. But is the Great Nothing really nothing? Not quite. The idea that voids are completely empty is a misconception. We have found a few rare void galaxies. These are some of the most isolated and pristine galaxies in the entire universe. Having formed in deep isolation, they have evolved without the constant collisions and interactions that shape galaxies like our own. They are a unique window into a different path of galactic evolution. What would it be like to live there? Ponder this. If you stood on a planet in a void galaxy and looked up at the night sky, it would be almost completely dark. The familiar river of the Milky Way would be gone. The nearest major galaxy would be an impossibly faint smudge, barely visible. Your entire civilization's mythology and science would be based on an assumption of near-total solitude in the cosmos. This brings us to the grandest implication. The existence, size, and shape of these voids are not random. They are a direct, large-scale consequence of the tiniest quantum fluctuations in the moments after the Big Bang. The minuscule differences in density in the early universe were magnified over 13.8 billion years of expansion, with the slightly less dense regions becoming the voids we see today. They are a fossil record of creation. Because of this, studying voids is one of the most powerful ways we can test and validate our entire cosmological model. By measuring them, we can refine our understanding of dark matter, dark energy, and the initial conditions of the Big Bang. The grand implication is that these vast, empty spaces are not an absence of information, they are rich with it. These empty spaces are crucial pieces in understanding the universe's past, present, and ultimate fate. They are the key to its blueprint. Thank you for watching.